So let's start with looking at this left-hand one. The first thing we're going to do is identify our zeros or our roots. That's way too many dots there. Where are our roots on this one? -4, -1, and what else? And 3. Are any of them having a multiplicity of 2? Which one? -1 has a multiplicity of 2. All that means for those of you that went to the senior meeting yesterday is this factor is going to be squared. It's a double root. So when we start writing this into our factored form, I'm going to zoom it in down here. Y'all have the picture. We're going to have our y equals or f of x equals. I don't care how you mark your function rule. What are our factors? X plus 4, x plus 1 squared, and x minus 3. Do we know our leading coefficient? Can we make the assumption that it's 1? No. If we don't know it, what do we put? A. It could be 1 because it's positive, but at this point we don't know, and it is a bad form to assume. I don't know why I'm making Captain Hook references, but it's okay. It's bad form. Bad form. Do we have enough information to find our A value? Could we find our A value? Are we going to find our A value? Yeah. So we're going to take that point that we have so graciously given you, where x equals 1 and y equals -8. And we're going to substitute those in for x and y. -8 equals whatever our A is, with our x of 1 plus 4, 1 plus 1 squared, and 1 minus 3. So we're going to have that -8 equals A times, and we're going to simplify these. 1 plus 4 gives us 5. 1 plus 1 is, squared is, so then square it. 2 squared is 4. 1 minus 3, -2. Why do we keep chanting 1? All right, so then we have -8 equals A times 5 times 4 times -2. -40. -40A also works. Yeah, totally fine. It doesn't matter what order we multiply it in. Divide -40 on both sides, exactly right. So we have -8 over -40 is our A. What does that simplify down to? 1/5. So our A value is 1/5. So we're going to take it back to our we didn't know A equation. We're going to put in the A we now know. y equals 1/5 times all our factors. X plus 4, x plus 1 squared, x minus 3.
So is that factored form?
That's factored form. And notice how our instructions say to write a polynomial in factored form. So do we need to multiply it out? No. Done with that one. But that's why you can see I said don't try and squeeze the graph into the bottom of the page. Okay. Questions on that first one? Make sure you clean all that up before you. Okay, thank you. Because this is literally the only class that's getting scissors. We're going to do the same thing over here. We got to find our roots, write our factored form, and then solve for a. So for this right graph, where are our roots? -3, -1, 0, and 2. That's a comma. Do any of them have a multiplicity of 2? The 0 has a multiplicity of 2. That means the factor's being squared. It's a double root, so it's bouncing. That's all the multiplicity thing is. It's just a fancy way of saying that factor will be squared. That's what we talked about yesterday. So we're going to start trying to put all our factors together. I'll do an f of x roll this time. F of x. Do we know our leading coefficient? No. So what do we put? A. What are our factors? X plus 3, x plus 1, x squared, and x minus 2. And it doesn't matter if you put your factors in different orders. Like, it doesn't. We just went left to right. It does not matter what order your factors are in. So now to find our a, what do we do? We're going to take this guy up here. We gave you a point on our line. We don't have to guess.
What if you don't?
Then you can't find a. Because if you try and use a root, it won't tell you about your stretch or compress, so a root won't work. So we can't use anything unless we give you a point.
Is it just a random point?
We've just selected a random point. Yeah, there's not any specific point. You have to have any point on the line of work. So we're going to substitute that in, and I'm zoomed in so I can't see my point anymore. So our y value is 16. We don't know our a, and we're going to substitute in our x of -2. And again, you don't have to necessarily write these all out. I'm going to so that we can see what they are, but if you want to simplify them as you substitute it in, I'm pretty sure most of y'all can do that. You should be able to do that. So you don't have to write down this step where you're substituting in, because it's a lot of writing. But if you want to write this step down, you absolutely can. But if you want to skip straight from this line to the one we're about to write where we've simplified them, I'm totally fine with that. Because what is -2 plus 3? 1. What is -2 plus 1? -1. What is -2 squared? What is -2 minus 2? -4. So yeah, I would 100% believe that you guys can do this to here without this middle step. Like, you don't have to write this step. You can. If it helps you, do it. But you don't have to. So we get that 16 equals A times what? 16. So what is A? 1. A can be 1. We just have to be able to prove that it's 1. We can't make the assumption. So we're going to substitute it in so that we have our proper equation. F of x equals, and you don't have to write the 1. It's always an assumed 1 if there's nothing there, so you can just skip the A. If you want to write it, you can. But you don't have to. Cool. Okay, questions on the how to do it from a picture? I feel like that's something we've done before, but it's just one of those things that they just want to go through it again. Okay, so I'm going to put up the first definition for tomorrow. We're not going to have time to work through it because honestly it's a lot of words. And I don't want you guys to have to try and rush through so we can work it today. So I'm going to put this up. It's called Descartes' rule of signs. It's a French name. This is still 4.3. We should be able to finish 4.3 tomorrow. And then we might be able to start 4.4, but we'll kind of see how tomorrow goes time-wise. So, but we will finish 4.3 tomorrow. So this is the first slide for tomorrow. So we'll see it again. But we still have 4 minutes. So you have time to write, like you have time. Okay, we will work with this tomorrow. It's when they get fancy people names, we always get a little scared because Descartes' rule of sign makes it sound really fancy. I promise it's not hard. Okay? But Descartes' rule of signs is one of those things that you will see. Honestly, I'll be a little surprised if you didn't see someone say Descartes' rule of signs on the PSAT or on the SAT because it sounds super fancy. Honestly, it's just a matter of how big you write your words. Like, seriously, we're going to draw a few arrows here on this, and then we'll use that same equation down here, and again, we're going to draw, like, a few little arrows underneath. We're counting a thing. So it's really not going to take much space to do the work on it. I just don't want us to, like, try and rush through it today. All we're doing is counting how many times does it change signs. From plus to minus, from minus to plus. Counting the changes. Yes, dear. You could like sum it up saying the number of positives is how many times it changes. On signs, it might be right off your words. But it's like, I'm not going to check how you write it. So if you want to put it in your own words, you can. But we're just counting the number of times it changes signs. But that gives us a chance to write it down before we get into tomorrow. Yes, dear. Yes, dear. Constant. So, hang on. Let me. Which was it for you? Just because looking at it in context, it'll be way easier for you to figure out what I mean. Oh, for these guys? So, this is your root. So secant, because it's in the remainder theorem we wrote it down, it was x minus c, because that's a constant there. So they're telling you the c is 2. So the factor of an x minus 2. So that is the root. So 3 is, into the box on the side. Yep. You're welcome. I'm always happy to clarify because, the book words things really weird. The wording is weird. And that's one of the reason I put weird words on my screen because they word stuff weird. But we don't get to Boop. Yep, going back, going back.
Thank you.